Okay, welcome. This is the second question I'm covering today. This was from the homework. This was how to find the intercepts of, and this was y equals 2x cubed minus 16. Okay, so finding the y-intercept, of which there can only be one, is fairly straightforward. What we want to do is plug in x equals 0, because anywhere on the y-axis the x-coordinate is 0. So that gives us y equals 2 times 0 to the third power minus 16. So that gives us y equals 0 cubed is 0, 2 times 0 is still 0, so 0 minus 16, or just negative 16. So the y-intercept is 0, comma, negative 16. Yes.
Is this simple 0?
No, it's t. Do you want some tea?
Do we just put this in the milk? Do we just put this in the microwave? Or?
Do you want to make bubble tea, or what do you guys want?
We want bubble tea, but we will make that once you're done with it.
Yeah, just give me a minute. Okay. All right.
Wait,
okay. So where were we? So this is the y-intercept, so where the graph of this function would hit the y-axis, where x is equal to 0. Okay, so for the y-intercept, for the x-intercepts, we're going to do the reverse. We're going to set y equal to 0. So that gives us 0 equals 2x cubed minus 16. We add 16 to both sides now. That gives us 16 equals 2x cubed. In order to get x all by itself there, we would divide both sides by 2. Then our 2's cancel, and we get 8 is equal to x cubed. And then here, to get x all by itself, what we want to do is find the cube root of 8. So the cube root of 8. So to find the cube root of 8, I think it's helpful to sort of think backwards, right? So remember that the square root of, let's say the square root of 36 is equal to 6. Why is that? Because 6 times 6 is 36. Okay, so to find the cube root of a number, we're going to be looking for the value that when it is multiplied by itself 3 times equals that number. Right? So with 8, it's fairly easy to reach that value because we can try 1. So 1 times 1 times 1 is 1. That's too small. We try 2. 2 times 2 times 2. That's 8. We get it right on the money. So the cube root of 8 is equal to 2. That gives us 2 is equal to x. And that's our solution. So that means that the x-intercept of this function here, the x-intercept is 2, 0. The y-intercept is 0, negative 16. Okay? So I want to talk about one possible place where, one possible situation where this could be a little different. And I'm going to ask you to imagine now that we have something like, let's say we have 0 equals x to the 4th minus 16 instead, right? So imagine that the original problem looked like this. Y equals x to the 4th minus, minus, not equals. Get a little bit of a fatter marker. There we go. So y equals x to the 4th minus 16. So again, here we would add 16 to both sides, and we get x to the 4th. We would take the 4th root of both sides of this equation. The 4th root of x to the 4th is just x. Those two operations cancel each other. And then we end up trying to find the 4th root of 16. Okay, so no problem. We're looking for the value that when multiplied by itself 4 times is equal to 16. Well, 1 times 1 times 1 times 1 is 1. That's too small. And 2 times 2 times 2 times 2, that's 16. So we've got it right on the money. Okay. Now, if you say that the x-intercepts of this function, if you say that the x-intercept is 2, 0, you only are half right, okay? Because the problem with this one is that, yes, in fact, it's true that 2 multiplied by itself 4 times is equal to 16, but that's not the only number that that fact is true of. It's also true that negative 2 times itself 4 times is equal to 16. So another solution, another place where this graph intersects the x-axis would be negative 2, 0. Both of these are x-intercepts of this function. Okay, so we don't have to deal with that in this particular case because while it's true that 2 times 2 times 2 is 8, negative 2 times negative 2 times negative 2 is equal to negative 8. So this one would not work. So there's only one x-intercept. But just be aware of that. Sometimes there can be more than one x-intercept. Okay, thank you.